Hello and welcome to Software Composition Analysis and Security Monitoring. I'm Andrew Conniff, a technical trainer at Microsoft, and in this video, we will continue our discussion of DevSecOps. Let's get started. When building and deploying secure applications, it's not enough to just write code that works. We need to make sure that it's created with security in mind from the very beginning. Inspecting and validating code bases for compliance means checking that our software follows all the necessary rules and regulations and that every feature is designed to be secure. This process helps teams avoid common pitfalls like accidentally introducing vulnerabilities or missing important compliance requirements that could lead to costly issues down the road. Software composition analysis is a crucial practice in modern DevOps pipelines. It focuses on managing the packages and components that make up our applications. By using tools like Azure Artifacts, teams can create a local cache of approved components and share packages such as NuGet, NPM, Maven, Gradle, Universal Packages, and Python. This centralized approach ensures that only vetted binaries are used, reducing the risk of introducing vulnerabilities. SCA also helps teams keep dependencies up to date and quickly address any issues that arise, making it easier to maintain secure and compliant software. Open source software components are widely reused in development, but they can introduce security vulnerabilities if not properly managed. SCA tools analyze the software to determine its composition, check for the latest versions, and verify the integrity of the binaries. Promptly addressing vulnerabilities is essential for protecting our applications and data. By integrating SCA into our workflow, we can proactively mitigate risks, ensure compliance, and build more reliable solutions. Scanning tools further enhance our ability to detect and resolve potential issues before they impact our organization. GitHub Dependabot is a powerful tool that helps keep our software projects secure and up to date by automating the process of checking for updates in our dependencies. It works by regularly scanning our project's dependency files, alerting us when new versions or security patches are available, and when a vulnerability is detected, Dependabot can automatically create a pull request to update the affected packages, making it easier for development teams to respond quickly to potential threats. This proactive approach means we don't have to manually monitor every library or framework our project relies on. Dependabot does the heavy lifting for us, so your code stays safe with less effort. Modern DevOps teams rely on software composition analysis to keep our applications secure and compliant. Here we're highlighting how SCA checks can be seamlessly integrated into a CI/CD pipeline. The process starts with developers submitting changes through a pull request, which then triggers automated static analysis scans of the source code. Tools like Mend, Checkmarks, Veracode, and Black Duck by Synapses can perform incremental scans, catching vulnerabilities and compliance issues before code moves further down the pipeline. By embedding these checks at multiple points, such as the version control, build agents, and release stages, we can identify and address risks early and reduce the chance of security flaws reaching production. When it comes to securing our software supply chain, choosing the right tools for assessing package security and license rating is essential. Here we're highlighting two main approaches: scanning centralized artifact repository and using tools during the build process in our pipeline. For example, solutions like Artifactory serve as artifact repositories, helping teams manage and scan packages before they're used in builds. Tools such as SonarQube provide static code analysis, catching vulnerabilities and code quality issues early. Mend Bolt focuses on build time scanning, integrating security checks directly into our CI/CD pipeline. And this layered approach ensures that both the source and the packages themselves are continuously monitored for risks. Automating container scanning is a crucial step in securing modern applications that use containers. Container scanning tools are designed to detect security issues in containerized applications, both at runtime and by inspecting container images for vulnerabilities and misconfigurations. Solutions like Microsoft Defender for Cloud, Microsoft Defender for Containers, and Microsoft Defender Vulnerability Management provide comprehensive protection by scanning images stored in Azure Container Registry and monitoring containers deployed in Kubernetes clusters. These tools help teams identify risks early, offer remediation guidance, and maintain a strong security posture across multi-cloud and on-premises environments. Integrating scanning tools directly into CI/CD pipelines, such as Azure Pipelines or GitHub Actions, enables automatic identification and remediation of vulnerabilities and compliance issues as part of the development workflow. This means every time a new container image is built or updated, it's immediately checked for security risks before deployment. Features like Dependabot and GitHub can also automate dependency updates in container images, further reducing exposure to known vulnerabilities. By making container scanning a routine part of DevOps, organizations can confidently deliver secure, compliant applications while keeping pace with rapid development cycles. Interpreting alerts from scanner tools is a vital part of maintaining secure and compliant software. When we run security scans on our codebase, the resulting reports typically highlight several important areas: security vulnerabilities, license risk, compliance issues, and outdated libraries. These alerts help teams quickly identify weaknesses or risks in their software components. For example, a vulnerable alert might point out a library with a known security flaw, while a license risk could alert us of a package with restrictive usage terms. By reviewing these reports, our teams can prioritize which issues need immediate attention and which can be scheduled for future updates. This ensures that our applications remain robust and compliant. Now let's look at monitoring and governance. Implementing pipeline security is all about protecting the identities, assets, and processes involved in our CI/CD pipeline. This starts with strong authentication and authorization. Using tools like multi-factor authentication and just enough admin ensures that only the right people have access to the sensitive resources. By managing permissions with role-based access control, or RBAC, you can tightly control who can do what within our pipeline. The pipeline itself should use an immutable structure, meaning changes are made only through the pipeline, making everything traceable and repeatable. Dynamic scanning, such as penetration testing, helps catch vulnerabilities in running applications before attackers do. Microsoft Defender for Cloud is a powerful security platform designed to help organizations protect their cloud resources and on-premises environments. It provides continuous monitoring and security recommendations for all of our services. So it's whether they run on Windows or Linux. Defender for Cloud analyzes our infrastructure, identifies potential attacks, and helps us respond quickly to threats. It also monitors our security settings and uses advanced technologies like Azure Machine Learning to detect suspicious activity. With features like just-in-time access control, we can limit exposure to critical resources, making our environments more reliant and more resilient against unauthorized access. It also monitors your security settings and uses advanced technologies like Azure Machine Learning to detect suspicious activity. With features like just-in-time access control, we can limit exposure to critical resources, making our environments more resilient against unauthorized access. Let's talk about how organizations use Microsoft Defender for Cloud to strengthen their security posture. In scenario one, imagine a company facing a security incident. Often teams only learn how to respond after an attack has already happened. That's why having an incident response plan is crucial. With Microsoft Defender for Cloud, you can manage incidents through three key stages: detect, assess, and diagnose. First, we detect suspicious activity using the dashboard, then assess the details of the alert, and finally diagnose the issue by investigating and applying remediation steps. Scenario two is all about being proactive. By configuring security policies in Microsoft Defender for Cloud, we can reduce the likelihood of major security events. The platform analyzes our Azure resources, identifies vulnerabilities, and provides a tailored recommendation to help us implement the right controls for our organization. Azure Policy is a powerful service in Azure that helps organizations create, assign, and manage policies to enforce compliance across cloud resources. With Azure Policy, we can define rules called policy definitions that automatically evaluate our resources and take action when conditions are met. For example, you may want to prevent virtual machines from deploying if they're exposing a public IP address, or require specific security configurations for storage accounts. Azure Policy comes with a wide range of built-in policy and initiative definitions, making it easy to get started and tailor compliance to our organization's needs. Policies in Azure are like rulebooks that help organizations maintain control and compliance over our cloud resources. A policy definition spells out what should be evaluated and what action should be taken. Think of it as a setting of a boundary for our environment. For example, we may want to create a policy to prevent virtual machines from being deployed with the public IP addresses or restrict the use of certain disks to control costs. These policies are written in JSON, making them both flexible and powerful. Assigning policies is straightforward. We can go to the Azure portal or use the Azure CLI or use PowerShell to apply them to specific resources, ensuring that our cloud stays secure and cost-effective. Once policies are in place, Azure automatically evaluates our resources against them and flags anything that doesn't comply. If a resource is found to be non-compliant, remediation steps can be taken to bring it back in line. This process is proactive rather than waiting for an issue to arise. The policies help catch problems early and keep our environment running smoothly. Initiatives in Azure Policy are like bundles of rules that help organizations manage compliance at scale. So instead of assigning individual policies one by one, we group them together into an initiative definition. It's a set of policy definitions aimed at achieving a larger compliance goal. For example, we might create an initiative called Enable Monitoring in Microsoft Defender for Cloud, which includes policies to monitor unencrypted SQL databases, operating system vulnerabilities, and missing endpoint protection. By assigning an initiative to a specific scope, like a subscription or a resource group, we can track compliance across multiple resources efficiently. This reduces the need for repetitive assignments and makes it easier to maintain a consistent security posture. So why use initiatives? Well, even if we start with just one policy, initiatives are recommended. If we want to increase the number of policies over time, they're going to be helpful. They simplify management, reporting, and remediation by grouping related policies together. This approach helps DevOps teams stay organized, ensures that compliance goals are met, and streamlining the process of enforcing security standards across cloud environments. Initiatives are a powerful tool for scaling governance as our organizations grow and our cloud footprint expands. Resource locks in Azure are a simple but powerful way to prevent accidental deletion or modification of our cloud resources. There are two main types: cannot delete and read-only. With cannot delete lock, authorized users can still read and change a resource, but they can't delete it. Think of it as a safety net for critical infrastructure. The read-only lock is even stricter. Users can only view the resource, not update or delete it, similar to someone giving read-only access to a document. These locks are managed directly in the Azure portal, making it easy for teams to apply extra protection to important resources. So why are resource locks so valuable? Well, in a fast-paced DevOps environment, it's easy to make changes that have unintended consequences. A simple mistake, like deleting a production database, can lead to downtime or data loss. By applying resource locks, organizations can add extra layer of security and governance, ensuring only intentional authorized changes happen. This helps us maintain stability and control costs and protect mission-critical assets, giving us all peace of mind as we innovate and scale into the cloud. Microsoft Defender for Identity is a powerful security solution designed to help organizations detect, investigate, and respond to advanced threats, compromised identities, and insider action within our networks. It works by monitoring domain controller traffic using specialized sensors, analyzing activity for suspicious patterns, and connecting to the Microsoft Intelligence Security Graph for deeper insights. The security portal provides a centralized dashboard where security teams can monitor and respond to threats in real time, making it easy to protect sensitive data and maintain a secure environment. What makes Defender for Identity especially valuable is its integration with other Microsoft security services like Defender for Cloud. By combining portal-based monitoring, sensor data, and cloud intelligence, we gain a comprehensive view of our security posture. This enables proactive threat detection, rapid investigation, and effective response to incidents, whether they originate from external attackers or malicious insiders. With Defender for Identity, teams can stay ahead of evolving threats and ensure their network remains resilient and trustworthy. Integrating GitHub Advanced Security with Microsoft Defender for Cloud brings together powerful tools to protect our development workflows. By onboarding GitHub organizations into Defender for DevOps through the Azure portal, we can create a seamless connection between our code repositories and cloud security services. This integration allows us to leverage Microsoft Security DevOps directly within GitHub Actions using the official Microsoft/security-DevOps-action@latest workflow step. The result? Automated security checks and continuous monitoring are built right into our CI/CD pipelines, helping our teams catch vulnerabilities and compliance issues before code reaches production. GitHub Advanced Security brings powerful protection to our code repositories by continuously scanning for vulnerabilities, secrets, and risky dependencies. In GitHub, these security features like code scanning, secret scanning, and dependency reviews can be enabled or disabled at the organizational or repository level. For public repositories, Advanced Security is always on, providing automated alerts and actionable insights directly within the GitHub interface. This means our development teams get real-time feedback about potential security issues, helping us fix problems before the code goes live. When using Azure DevOps, GitHub Advanced Security extends its capabilities to Azure repos. You can turn on features like secret scanning and code scanning at the organizational, project, or repository level, and these tools integrate with your CI/CD pipelines, automatically checking for exposed secrets and vulnerabilities every time code is pushed or built. By adding dependency scanning tasks to our pipelines, we ensure third-party packages are safe and up to date. This proactive approach empowers DevOps teams to maintain high standards of code quality and security, making it easier to deliver reliable software while staying ahead of threats. Now let's move to a demonstration and explore these tools in action. We can visualize our solution's threats using tools like Microsoft's Threat Modeling tool. Here we can label our resources, our trust borders, and the path our data travels, ensuring encryption at rest and in transit. It also informs us where we can optimize networking and processes safely. Adding a new resource is easy. Just drag the icon onto the canvas. Once there, we can integrate it into our solution. In GitHub, we access our security configuration through repository settings. We can choose which reporting tools are active and configure Dependabot features. In Azure, we can access Microsoft Defender for the cloud. Here we can set up our environments, view recommendations, investigate path analysis, and view security alerts. Cloud Security Explorer allows us to query our resources and includes many query templates to choose from. The Workbooks tab shows our Defender workbooks and quick starts for customization. Here we see the DevOps Security Workbook, and we see a large community is available for information and to contribute to. Microsoft Defender for Cloud includes a robust troubleshooting guide. We can also track our security posture and regulatory compliance, workload projections, and data and AI security. And here we can investigate our network security and create tools to mitigate tasks. In the DevOps security section, we can connect to our environments and set the policy and governance rules. We can set per environment rules and exemptions here as well. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning /mslearn-devops. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.